Hello Brainerds, my name is Jace and welcome to the Big Brain Busters. So in this video I'm going to take you through isomerism and cracking. I hope you checked out our first and second video on organic chemistry where I introduced organic chemistry and talked of alkanes. So this is part B of video 2 where I'm going to talk about isomers of alkanes and cracking of hydrocarbons. With that being said, let's proceed. So what is isomerism? Isomerism is just simply existence of compounds with same molecular formula but different structural formula. So you find that organic compounds may exhibit isomerism by having the same molecular formula, but when you try to draw their structural formula, it is actually different. So such a characteristic is what we term as isomerism. Then when you talk of isomers, isomers are simply compounds having the same molecular formula but different structural formula. So this is how you differentiate between isomers and isomerism. Then another thing that I want you to take note of is that alkanes with more than 3 carbon atoms exhibit isomerism. So what I simply mean by that is that I'll give an example of methane, ethane, and propane. Okay, so methane, ethane, and propane, these guys, so in short, alkanes having less than 4 carbons do not exhibit isomerism, and I'll show you why they do not exhibit isomerism in this case. So these guys, the first 3 alkanes only have got one structure. Okay, so they only have one structure, meaning that they only have one isomer. Then alkanes with more than 3, so meaning that here with more than 3, meaning that we'll start from butane itself having 4. So butane has got 2 isomers. It has 2 isomers. When you try to draw its molecular structure, it has 2 isomers, okay, of itself. So this one exhibits isomerism, and structures even having 5, 6, and so on and so forth, they exhibit what? Isomerism. Okay. Then one thing I want you to take note of is that I thought it would be much of importance is that when you get any alkane, I'll give an example of methane. When you get any alkane and subtract one hydrogen, you will get an alkyl group. Okay, so in this case, if you have methane, you subtract one hydrogen group, you get CH3. So this CH3, it will no longer be called methane, it will be called a methyl group in this case. So it will be called a methyl group. Okay, then let me use another example of ethane again. So ethane has got the structure of C2H6, or its condensed formula, which is CH3. This is the same thing, by the way. This is the same thing. This is the normal formula, this is the condensed formula. So when you subtract one hydrogen, you will get CH3, CH2. So this will no longer be called ethane, but instead it will be called what? Ethyl group. So it will be called an ethyl group. So as when you get for propane, you remove one hydrogen, it will be called propyl. Butane, butyl, in that manner. Okay, so these guys, these methyl groups, ethyl groups, propyl groups, these guys are the ones that we actually use in they're the ones we displace when drawing the structures of isomers. Okay, when drawing the isomers, and mainly you are going to be dealing with methyl group. The methyl group, it will be the most common group that you are going to be dealing with for grade 12 level. Okay, with that being said, let's proceed. So let's look at naming of isomers of alkanes. So when we talk of naming isomers of alkanes, we talk about this organization which come up with rules. So this organization is called the International Union of Pure and Applied Chemistry. So these guys come up with rules that we follow to actually name what? Alkanes. We don't just name our alkanes. So Okay, so let's talk about those rules. Okay, so in this case we're going to use butane as our example to illustrate what we want. So let's talk about the rules. So we have the first rule, which is choose the longest continuous carbon chain in the molecule. So first of all, let's look at the structure for butane. So the structure for butane, this structure for butane, as you are already familiar with it, it has 4 carbons in its chain, right? Then, to choose the longest continuous carbon chain in the molecule, we will displace, first of all, we'll displace one methyl group and place it in the carbons, in the middle. Don't place it in the carbons at the far end. Don't place the methyl groups that you have displaced at the far end here. So that's one way I try to, like, remind myself to say never place the methyl groups at the far end carbons. Only place it in the carbons in the middle. Okay, so we'll get any of the we'll get either this guy or we'll get this one. Here we can only get one. Okay, remember, don't place it at the far end, so meaning that we can only get one methyl group and place it uh, in the carbon chain in the middle. All right, so when we place it there, it will look something like this. So as you can see, we have removed one methyl group, either this side or this side, and placed it in the middle there. Then we will remain with only 3 there in the middle. So the the first rule that we are following is that choose the longest continuous carbon chain in the molecule. So which one will be your longest carbon chain in the molecule? Is it this one or this one? So you just choose which chain has got more carbons in the series. So as you can see, in this direction you have 1 2 3 carbons. In this direction you have 1 2 carbons. So which one is the longest continuous carbon chain? So the continuous carbon chain is in this horizontal direction. So that's what we are doing in the first rule. We are just choosing the longest continuous carbon chain. That's all. So we are done with this rule. We've obeyed this rule by choosing the longest continuous carbon chain. That's all. Then our second rule is simply name the compound as a derivative of the normal alkane having the same number of carbons as in the longest chain chosen. So what this rule simply means is that after we determine our longest chain, we name the compound as a derivative of the normal alkane. So we name this chain here. So remember, when naming alkanes, we say that whenever you have 3 carbons, what is the compound code, or what is the alkane code? It is called what? Propane, right? With 3 carbons. So meaning that in the longest chain it is called propane. So this is propane. Okay, but this is not the full name of this. This is not the full name of this uh, you know organic of this isomer here for butane. It is no longer called butane. It will be called propane at some point, but this is not the full name. We do not call this compound as propane in this manner, no. But there are some rules that we need to follow again to come up with the full name for this structure that we have put about right here. So with that being said, let's continue to look at the other rules for naming isomers. So the third rule actually is number the carbon atoms in the longest chain chosen, starting from the closest to the branched methyl group. So here, as you can see, this is our branched methyl group, right? So you look at which position is our branched methyl group. So in this direction or this direction, you look at which carbon is closest to this branched methyl group. And when you look at the carbon which is closest to this branched methyl group, that's where you start counting. You number them. You number them in that order to say 1 2 3 4 in that order. Okay, so in this case, as you can see, this branched methyl group is actually in the middle, so meaning that you can either start from this side to say 1 2 3, or you can simply you can start from this direction. You can start from this side to say 1 2 3. Okay, so in this case we'll name it number 1, number 2, number 3, in that direction. So we are done. We are done. We've obeyed this rule. We've numbered our carbons. So let me just give another example of whereby which will give more sense to this rule. So let me just give an example of let me put 4 carbons. Let me put 4 carbons. Then let me say our methyl group is here. I won't draw the hydrogens for the other carbons. Just know that they are hydrogens. So let's say this is our this is something like this. I just want the rule to make sense. So let's say you have 4 in this manner. Okay, you have 4 carbons in this manner, in this longest chain. So what will happen is that when numbering these carbons in the longest chain, what will happen is that we'll start from the carbon atoms which are closest to the branched methyl group. So as you can see, the branched methyl group is here. So the carbon which is closest to the branched methyl group is this carbon here, not this one. So meaning that when numbering, we'll start from this side. So we'll start from 1, 2, 3, and 4, like that, in this direction. Okay, in this direction, not this direction. No, not in this direction. This would be wrong. So here we started from this side going this side because the branched methyl group is in the middle, so we can start from either direction. We can go this side or this side. That's why it was pretty a bit easy for this one. But to follow this rule properly, this is what you do. Okay, this is what you do. I hope it makes sense. Alright, so let's proceed to the next rule. So the next rule says that we should write the number of carbon atom at which the branched methyl group is attached to the chain in alphabetical order. So what we mean by alphabetical order, remember that we had methyl group, methyl, and ethyl groups, and propyl groups. So this one, you find that in very complex isomer systems, that's where you find that this rule will actually mainly apply. So you find that you have methyl group, ethyl group, propyl group. So in alphabetical order, what we simply mean is that methyl, you look at the alphabet, methyl, M, and ethyl. If you have methyl group and ethyl group in your compound, so you look at the one which will appear first in the alphabetical order. So in this case, you find that E is first in the alphabetical order. So meaning that when naming your organic compound, you start first of all with ethyl, then you proceed to say methyl. You don't say methyl then ethyl, no. Then if you have propyl as well, so you also say propyl. So you name it in that manner. So if you have a methyl group and an ethyl group, so you start by saying ethyl, methyl. I hope it clicks or perhaps makes some sense out of that. So that's what rule number 4 rather is actually telling us to do. We name our carbon atom. We write the number of the carbon atom at which the branched methyl group is attached in alphabetical order. So let's say, for example, let me just give an example of something. Let's say this is something like this. So let's say on this carbon we have a methyl group. Oh, sorry, we said methyl, it's actually 3. Then let's say to this carbon compound we have an ethyl group. So CH3, CH2. So this is an ethyl group. So what will happen is that we will do this. So let's say this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So what we'll say is, we will say, since F starts first in the alphabetical order, so we'll say 2, alright, so 2 what? 2 ethyl. Then we'll proceed to say what? Comma. So then on which position is the methyl group? The methyl group is on the third position. So 2 ethyl, 3 methyl. That's what we just simply mean in alphabetical order. So this is what we simply mean by that. Then if, for example, if we had the methyl group, let me wrap that. If we had the methyl group and ethyl group, let's swap the positions. Let me just swap the positions. So let's say on carbon number 2 we had let's say on carbon number 2 we had the methyl group. Then on carbon number 3 we had the ethyl group. We had the ethyl group. We would have said 3 ethyl. Again, we follow the same alphabetical order. Despite the position or despite the number on which that group is on, we still follow the order, the alphabetical order. So in this case, we say 3 ethyl, comma, 2 methyl. Okay, so in this manner, we would have followed that, direction. Okay, so I hope it makes sense. So let's proceed. So remember, we are using butane as our example to derive our isomer for butane. Alright, so let me just wrap this. Let me just wrap this guy. Okay, so that's what we came up with. So in this case, this guy, this this methyl group, on which position was it? It was on position number 2, and since it is on position number 2, so we'll say 2 methyl. Then remember that the long chain is what? We named it as what? Propane. So this is the name of this isomer for butane. So butane has got 2 isomers. The first one is butane itself. Then the second isomer for butane is what? It is simply 2-methyl propane. Then you're done naming the isomers of butane and drawing it. This is the drawing. This is the molecular structure for the isomer for butane. Okay, then the fifth rule here for our example, the fifth rule couldn't apply, so I just dropped an example to show you actually something where the fifth rule will actually apply. So put a comma after each group number and a hyphen between the group number and the methyl group. So in this case, as you can see, we were putting commas. Okay, we're putting a comma, and a hyphen when naming the methyl group there. So that's what the fifth rule, is actually just telling us to say. We put a comma to differentiate the numbers. So we'll say carbon number 2, carbon number 3, carbon number 4. So these numbers are just simply telling us on which positions the methyl group or perhaps the ethyl group is actually belonging to. So we put commas to differentiate them, then and a hyphen to, after we write the numbers, we put a hyphen, then we write the name of the group. Okay, so in our example is just telling us to say draw the structure of the compound with the International Union for Pure and Applied Chemistry name 2,3,4,4 tetramethylpentane. So in this case, they've given us the isomer, then they want us to draw the structure of the compound. So in this case, first of all, we will start by obtaining to obtain the longest carbon chain. So the longest carbon chain in this case is pentane. So meaning that the longest carbon chain should have 5 carbons. Okay, so there we have it. So we have 5 carbons in this chain. Okay, then the next thing is that we should also determine where the methyl groups, since remember that they're saying tetramethyl. So tetramethyl, in this case, will have, methyl groups will have 4 methyl. Tetra means 4, so meaning that we have 4 methyl groups on carbon number 2, carbon number 3, and 2 methyl groups on carbon number 4. So let's draw how this structure will actually look like. So first of all, we'll name our carbons. So as you can see, 1, 2, 3, 4, 5. Then let's now place our methyl groups. So let's place the one on carbon number 2. So we've placed the first one on carbon number 2 there. Then on carbon number 3 as well, we've placed the methyl group on carbon number 3. Then let's place the 2 methyl groups on carbon number 4. There we have it. So these are the methyl groups on carbon number 4. So this is the structure for 2, 3, 4, 4 tetramethyl pentane. This is what they wanted us to draw for this example. All right. So for your practice exercise, you can try to answer these questions that I've just set up, and if you manage, well, that is very good. Congratulations to you. Then if you perhaps have challenges, I'll drop my number so that you can inbox me and try to perhaps confirm your solutions and ask questions. All right, let's proceed. Now, for the last thing that we're going to look at in this video, we're going to look at cracking of alkanes. So what is cracking? So cracking is just simply breaking down of large hydrocarbon molecules into simpler and smaller molecules. So that's what we mean by cracking. To crack, to break. Okay, so we break large hydrocarbon molecules to make simpler ones and smaller ones. So in this case, alkanes break down to produce alkenes, short chain alkanes, and some cases hydrogen gas. All right, so the types of cracking that we have is simply thermal cracking. So thermal means what? It means temperature. Okay, so it's something to do with what? With heat. So in this case, thermocracking deals with breaking down of large molecules into smaller ones in the presence of what? Heat. An example is this compound here. So this compound, will break it to form what? We will form ethane and ethene. So we've broken down this hydrocarbon to form ethane and ethene. Another example is of ethane. Ethane will break it down to form what? To form ethene and hydrogen gas. Right? So I hope that makes sense. Then let's look at catalytic cracking. So when we look at catalytic cracking, in this case meaning that there is an involvement of what? Of a catalyst. So this is where both heat and the catalyst are actually used to break down large molecules into smaller ones. Then the most common catalysts include aluminum oxide and silica. Okay, so this is an example that I've placed here where we break down this entire hydrocarbon into smaller hydrocarbons. All right, then the conditions are that you must have a catalyst, which is aluminum oxide, and another condition is that you must have your temperature at 600 degrees Celsius. What is the importance for cracking? So the importance for cracking is that it is used to produce raw materials for petrochemicals such as ethene and hydrogen. So as you know, like when you break down large hydrocarbons, you find that you produce very useful, so hydrocarbons such as ethene, and of which ethene, when you polymerize it, you can actually use it to make, you can actually use it to make what? You can use it to make plastics. Then hydrogen, it can be used as a fuel, or you can use it to make margarine. Okay, so as you can see there, hydrogen is used in making plastics and margarine. Then the second importance is that it is used in the production of petrol. So when you crack down large hydrocarbons, you can also use when you crack, you can actually produce petrol, okay, which is used as a fuel. Okay, let's proceed. So here is an exercise, okay, an exercise of which I want us to answer. So one of the hydrocarbons found in crude oil is andecane. So andecane is actually an 11 carbon alkane. Under suitable conditions, andecane undergoes the reaction below. So this is the reaction that andecane undergoes, and it when it has, when it undergoes this reaction, it forms this guy and this guy. So the first question says, what term is used to describe this type of reaction in petrochemical industry? So the term that is used to describe this type of reaction, as you can see, this andecane alkane has been broken down, so into to form what? To form other hydrocarbons. So meaning that this term, this guy, so let's just write our solutions there. So for A, the actual the term used is actually called cracking. Okay, cracking. To be specific, it should be catalytic cracking. Okay, it should be catalytic cracking. Then B tells us to say state two conditions necessary for this reaction to take place. So for catalytic cracking, number one, you must have a catalyst, which is aluminium oxide or silica. Okay, aluminium oxide or silica. Then our next condition is that you must have a temperature of about 600 degrees Celsius. All right, that's it. Then we've answered this question. Okay, so thank you very much for watching this video. This is the end of our video. Please check out our next video for organic chemistry playlist. Enjoy your day. Shalom shalom.